4, Notes and Practice. So this is our first lesson in the new unit on Unit 6, which is solving radical and rational equations. So in this unit in this lesson we're working on our solving radical equations. But first, let's start with a little review of absolute value. So here it just asks you and reminds you how you solve absolute value. So if you remember from September, we actually did this in the very beginning of the school year. How do we solve an absolute value equation? So you want to get the absolute value portion alone first. You do that in this case by adding 5 to both sides. So you would add the 5 on the left side, you would add the 5 on the right side. And that's what we do right here, what it's called isolate that absolute value. So we're going to isolate that absolute value by adding 5 on both sides. Once we do that, then we're going to split into 2 equations or inequalities. Now in this case, these are absolute value equations. So we're just going to split into the absolute value equations. So to show that, again, here, the x plus 4 minus 5, we've got our x plus 4 minus 5 equals 8. So again, I'm just going to go through with this, but on here, so I'm going to add 5 to both sides. When I do that, then what I should look for is the absolute value alone? So in this case, it is alone. And now we say, okay, is it equal to a positive number? Remember, an absolute value cannot equal a negative. Since it is, we're going to split into 2 equations. So one, we just copy the exact same thing that we see here. The other, we keep what's inside the absolute value the same, and we what's called negate what it said equal to, which means we're going to switch that sign. And now we're just going to do the pre-algebra to solve for the variable. So I minus 4 on both sides. I get x equals 9. I minus 4 on both sides. And I get x equals negative 17. So those would be my 2 answers. So in terms of this, it asks you to just kind of type them in. So then those would be your 2 answers there. All right, so that's a review, and hopefully you'll see during this lesson why we're using that as review topic, because there's some similar characteristics to what we're doing. So the second part of our review warm-up here is identifying the index. So remember, when we write this, the radical sign is the symbol here, and then the index is this number written out here. It's called the root or the index, okay? If there's no number written there, it's a 2. So here I see an index of 4. Here I don't see any number written there, so remember that's implied to be a 2. So we put a 2, and here this is a cube root, so you'd see that, you'd put a 3. Okay, so those are the roots index, and that's going to be important because as we're solving these equations, we're going to have to cancel them. So we have to do the opposite of the index. So we got to know what the index is in order to cancel it. All right, so let's look at a pre-done example here. So here are the steps that you see on the right-hand side. So we need to isolate the radical. So in this case, isolate the radical means we need to get this square root of 2x minus 3 part alone. So here I see that it's adding, the 3 is adding here, so we're going to subtract 3 to cancel it to get here. From here, when it says raise each side to the power suggested by the index, that means if it's a square root, we square it. If it's cube root, we cube it. Fourth root, we take it to the 4th power, and whatever. So in this case, it's a square root, so we're going to square both sides, right? So the square and the square root cancel. So you're left with 2x minus 3, and then 5 squared, which is 25. Now if we get here, this could be really easy or a little bit complex. Depends. In this case, this is really easy for us. This should just be pre-algebra. So we're going to add 3 to both sides, divide by 2, we get x equals 14. And then how do we check it? So we're going to take the 14 and plug it in for x. So you see it pre-done here, and then if I was going to do it to show you in the calculator, I'm going to just type in this equation that I see right here, and I'm going to put the left side in here, and if it equals what it says on the right, which is 8, I know I'm correct. So here it's 3 plus, and now I need the square root, so I use the square root, and then 2, and then x, but we just solved for x, right? We got 14, so 14, and I'm going to close the parentheses, and then minus 3, and what do we get? We get 8. So there you go, boom, 8. Okay, so I know that this worked. So then let's show when we're actually doing the work. So isolate the radical. I see the fourth root of 2x. I need to get that alone. So to cancel the negative 5, I'm going to add 5 to both sides. So when I do that, I get the cube root, or sorry, 3 times the fourth root of 2x equals 4 plus 5. 4 plus 5 is 9, divided by 3, divided by 3. That gets me to the fourth root of 2x equals, well, 9 divided by 3 is 3. So now I'm going to take both sides to the fourth power, because again, we are going to raise each side to the power suggested by the index. So this is a fourth root, we take it to the fourth. So that's going to cancel. So now I get 2x equals, all right, 3 to the fourth power. Well, if you don't know it, just go here, 3, and then this gets you that exponent. So 3 to the fourth, we get 81. Now I need to solve. Well, in this case, that's pretty simple. I just divide by 2 on both sides. So I get x equals 40.5. Okay, so x equals 40.5. All right, so what does that really mean for us, right? That means this should be the answer that if I plug in this left side to check, gives me 4. So let's try it. All right, so I'm going to clear this, and I'm going to type in 3. And now I want that fourth root. So I hit this root button right here with that n there. And now see, I can plug a 4 in there. That gets me what I want. So now I go 2, open parentheses. Well, what was my answer? 40.5, close parentheses. And now here's a key here. Notice how this negative 5 is outside. So I hit the right-hand arrow key to get outside it. Now I do minus 5. See how I get 4. So that confirms that my answer is correct. All right, so that's one type. So now let's look at another type that's a little bit trickier just because of what happens once we cancel the radical. All right, so here I see that I have the x plus 7 minus 5 equals x. So now I need to isolate the radical. So again, what is that going to mean here? Well, I see the minus 5. To cancel minus 5, I add 5 to both sides. So now I get here. So now I need to raise the power suggested by the index. It's a square root, so I square both sides. The key here really is this step. So remember, when I have x plus 5 squared, that really means I do x plus 5 times x plus 5. That's where my x squared plus 10x plus 25 comes from. So now, what happens? You need to think about, how do I even solve from here? Well, let's remember, this is a quadratic equation. So really, we just have a problem from the last unit. So we need to get it set equal to 0. So we're going to minus the x to both sides, minus the 7 to both sides. That gets us here. And now you can solve with any of the methods. You could factor, you could graph, you could quadratic formula. In this case, I would just factor, because it's pretty simple factoring, right? Multiply to 18, add to 9, would be 6 and 3. And then we're going to set it equal to 0, okay? And then solve, so I get x equals negative 3 and x equals negative 6. But as we said before, you have to check. So you can check by plugging your number in the calculator, the way I just showed in the previous one. And you'll notice when I do on the left side, I get negative 3. And it's supposed to equal the x value, which is also negative 3. So for the negative 3's, they work. But when I plug it in for negative 6, it does not work. So I get negative 1 equals negative 6, which is not true. So this answer is what's called extraneous, meaning you did all the work correctly, but it still doesn't check out. So negative 3 is my only solution. Obviously, this is a little bit of a trickier type problem because of the fact that you get a quadratic here. All right, let's look at a problem like that and do it ourselves. So I need to get that radical alone. So I subtract 3 from both sides. So now I get the square root of 5x minus 1 equals, and then x minus 3. So now raise it to the power suggested by the index, which means I'm going to square both sides. So I go square, square. So on the left side, they just cancel. So I just get 5x minus 1. And on the right side, I've got this. So remember, again, what does this actually mean? It means x minus 3 times x minus 3. So I'm going to multiply through x times x squared. x times negative 3, negative 3x. Negative 3 times x, negative 3x. Negative 3 times 3, 9. It's a quadratic equation. I want to get the one side equal to 0. So the easiest thing is for me to move everything to the left, from the left to the right, since my x squared is already on the right hand side. So let's do that. So I get 0 equals, and now I've got x squared, and then I've got negative 3x, which is negative 6x, negative 5x, which is negative 11x. 1 plus 9, 10. Okay, so now this is where I'm at here. Okay, so next I'm going to multiply to 10, add to negative 11, which should be negative 10 and negative 1. So you notice it said I picked factoring. You don't have to do that. I would tend to if the problem is pretty easy to factor. If it's more difficult, I definitely would pick a different method. So now we just are going to solve. So remember, you're going to set each of these equal to 0 like we discussed in the last unit. Zero product property rule. So now I would solve both of these. You know, obviously you can kind of go through these mentally, but I'm going to get x equals positive 1, and then x equals 10. Now, once I get here, I am going to want to check. So I'm going to plug these two answers back into my original problem to see if I have any extraneous solutions. So again, I'll show how to do that here. So notice how it's this whole side equals x. So whichever x I'm picking, when I plug it in the left-hand side here, it needs to equal that value of x. So let's start with plugging it in. So square root of 5 times 1 minus 1, and that's all underneath the radical, and the plus 3 is on the outside. So we go outside it plus 3. So notice I get 5. What's supposed to equal x? It equals 5, not 1. So this answer would be rejected. It would be extraneous. So then for my other one, let's just go back in here and change this to a 10. Did I get 10? Yes. So this would be the accepted answer. Okay. All right, the last method is pretty easy. So it's when you have just one radical of a certain type equaling another radical of a certain type. And so notice there is no step to isolate the radical because they already are isolated. So raise each side to the power suggested by the index. We just square both sides here to cancel. And now from here, I mean, you basically just have an algebra 1 problem, right? So solve for x. You get x equals 6. Great. Then from there, plug into the right side, plug in the left side, and they should equal each other. We get square root of negative 8 equals square root of 8 equals square root of 8. They check, so we know we're good. All right, so let's show it one time. So I'm going to square both sides since they're both square roots. So when I do that, cancel, cancel. So I'm left with 3x equals x plus 6. And now I'm going to solve for x. So minus x to both sides. Remember, this is a 1x. So if it helps you to put 1x there, please do it. So now I get a 2x equals 6. I'm going to divide both sides by 2. I get x equals 3. And now this one's so simple, I'll just check it in my head. 3 times 3 is 9. The square root of 9 is 3. 3 plus 6 is 9. The square root of 9 is 3. So it checks. Alright, then you have your asynchronous work, which is to do screens 11 through 14. So make sure you get that done. Hope this helps.